Good morning, everyone. I trust you had a good week last week, and trust some of you took the opportunity to catch up and that you're now all up to date. So hopefully, if that's the case, you'll all have no trouble completing the square for these three example quadratics. Okay, I've made them y equals functions because what we're going to be doing is doing the first thing that completing the square does, and that's allow us to sketch functions accurately. So have a go at that, pause the video, and then we'll pick it up in a moment. Okay, so here's the first one. I mean, I haven't gone through the full process of working. I'm hoping that you're okay with that now after the practice you did before half term. But this is what we should have ended up with. And I'm now going to see if I can use this to help me sketch this function. So I'm going to go through the process of sketching x plus 3 squared minus 12. I'm going to start with a function that I know how to sketch, and that is y equals x squared. Y equals x squared is nice and easy, looks like this. Hopefully you remember from GCSE that when you replace x with x plus 3, that translates the whole function 3 units in the negative x direction. So you end up with a function that looks like that. And then finally, if you take that and you take away 12 from the whole function, it shifts the whole function down. Okay, so this is not to scale, but it shifts it down to 12. Remember, this is the opposite effect. We get shifted backwards 3 units, but this is the same effect. So we end up with a function that looks like this. And in particular, that turning point has the coordinates -3, -12. Now, as to the location of this point and the location of where the graph would cross the x-axis if I'd carried on drawing it, well, I'm not going to worry about that today. Some of you will remember how to do that, and in fact this point's really, really easy. But it's the fact that the turning point is located at -3, -12 that is important. Now, there were 2 steps of transformations that happened, and the order is really important. So it is important that you do the x translation first and then the whole function translation. Okay, here's the second one. Again, this is quite a complicated process, isn't it? Which I haven't gone through, but you should have ended up with this answer here. So I'm now going to sketch this one. And so here are the steps. There's an extra step in there this time, isn't there? So I start with the thing that I know how to sketch. That's y equals x squared. I then do my x translation first. This time I've replaced x with x minus 2. So that means it's been shifted forwards 2. Sorry, let's go for green. Forwards 2 in the x direction. So it looks like this. I then multiply the whole function by -1. And you may remember whole function by -1 is a reflection in the x-axis. So it looks like this. So I've got to that step there. Then I add 5 to the whole function. So that lifts up the function and, again, not to scale, but brings me up to there. Getting the right colour, should be in black. And I get something that looks like that. Now, actually, I've done my sketch going through the origin. It doesn't go through the origin. It should go through +1. We'll do that in the next video. But the key thing for me is the location of that turning point, which is 2, 5. And knowing this point is important. And you'll see when we do the end of chapter 2 how we're very often with a quadratic, we're modelling something that's moving, the motion of something, a projectile. So knowing where the projectile's maximum point is really important. Again, the order here is key. The first thing I did was the x direction shift. The last thing I did was the whole function shift. The reflection came in the middle there. Let's do the last one. So here's the last one. Quite, again, a complicated process to get from here to here. I haven't gone through that whole process, but hopefully you get the same answer as me. So let's look at how we can sketch that one. So here are the steps that I need to take. Again, I'm going to start with something that I know how to sketch, y equals x squared. I'm then going to do the x direction translation. Adding 3 to the x moves me backwards 3. Now, we didn't do this at GCSE, wasn't on the syllabus. Multiplying the whole function by 2 is a stretch. You've got to imagine that the graph is fixed to the x-axis and it gets stretched with a scale factor of 2 both up and down. Well, there's nothing below the x-axis. So all it does is doesn't change the location of the turning point at all, just stretches it up a bit, makes it skinnier. You've got to imagine it was on elastic. If you stretched it up, it would look skinnier. And then the last step is we take away 14 from the whole function. Again, very much not to scale here. So that means the function looks something like that. And the key thing for me is the location of the turning point is that. Now that's all very well, but you might think, well, actually, I'm not convinced you've got that right. I'm not convinced this is where the turning point is. So we can use our calculator to confirm this. So I'm going to take my calculator and I'm going to put it in graph mode. I did that by going to menu and selecting graph, which was the one underneath the normal mode. If there's anything there already, you can press delete and delete it. And I'm just going to type in this function as it is. I'm already in y equals mode. There are other functions you can type in, but we're in y equals mode. If you've got out of that, that's a type function. So I'm just going to type it in using the x button here. 2x squared, simple as that, plus 12x plus 4. And press XE. And I go to draw. Can't see it. And that's because the last thing I plotted was a trig function, a sine or a cos curve. So my axes are really odd. They're scaled for trig. So I'm going to go to the V window button, which is where you set up your axes. And you've got two really useful buttons here, trig and standard. Trig sets it up with a sort of decent set of axes for trigonometric functions, and standard is for normal functions like this. So I'm going to select standard, and that's gone from -10 to +10 in both directions, in the x direction and the y direction. Remember the dot function, just leave it. The scale is how often you get the tick marks. So I'm going to exit from that to get out of that page. Annoyingly, it takes me back to that page, so I have to then go to draw again. Now I can see it. I still, however, can't see the turning point, so I can use two buttons. I can either use the plus and minus button to zoom in and out, or I can just use the cursor to scroll down, and that allows me to locate the turning point there. I then get to use when it looks like I've got it right, it looks like -3 for -14, but let's double check by using my favourite button on the whole calculator. That's the G-solve button. And I want to find the minimum of this graph. So I press minimum and it confirms that it's -3, -14. Now, okay, why do we bother doing all this malarkey if we've got a calculator that does it for us? Well, firstly, not all schools give you a graphical calculator. So there you go, that's a tick in the box for Ilfracombe Academy. But secondly, exam boards are very good at asking questions with missing letters instead of numbers, so they're very good at getting around that problem. So we need to be very good at this technique, even though we've got a calculator that allows us to check the answer in this case. So your task for today is nice and easy. Here are 3 other quadratics. I'd like you to go through the same process. I'd like you to complete the square. I'd like you to sketch them using the step-by-step approach that I recommended. And then I'd like you to check them using your calculator by not typing in the completed square version, but typing in the original version and just checking that you get the same turning point as the calculator gets. And on Friday, next lesson, we will take it on a step. Get in touch if you've got any problems. Hope you're all well.